So the question says, an object is projected at an angle such that the horizontal displacement is 3 times the vertical displacement, or the vertical height, the maximum height. Okay. The maximum height. Okay. This is the key to our statement. That is the key to our statement. Horizontal displacement, when we project something at an angle at 270, it is going up, it reaches a maximum height. Then it drops somewhere. Then this is your horizontal displacement from point A, from where it was launched to where it drops. This is your horizontal displacement. Now, on our horizontal displacement, what we said is that the velocity at which it moves, that velocity, the velocity going horizontally is a constant horizontal displacement. Remember I said the things you need to know are only 3 about projectiles. You need to know how to get the maximum height, you need to know how to get the time, you also need to know how to get the horizontal displacement. So we'll still do all those three, but we'll do them without knowing the angle. We are solving for the angle, but we need to know how do we get the horizontal displacement. Horizontal displacement, what we said is equals to the velocity, horizontal velocity, times the time it took to go up, then we multiply by 2, going up. So this alone can be substituted by both. Okay, the horizontal displacement in this case it is 270 cos theta. We don't know what theta is. That's what we are solving for. Times the time times 2. So now the next thing in this whole equation, the next thing that we need to sort out is what? The time. And what did we say? Where is the time hiding? The time is hiding in that maximum height. How were we solving for the time? So at this point, we cannot take this one in there. We need to figure out what is our time. Time, we said we will use the vertical movement. On the vertical movement, we said the final velocity is going to be 0. Initial velocity is 270 what? Sine theta. Vertically, gravity, since you are going up, gravity is going to be negative 9.8. Then t is what we are solving for. With this, we are just trying to figure out what t is. With this, we say t is equals to the final velocity minus the initial velocity over gravity. We'll say 0 minus 270 sine theta over negative 9.8. So negative 9.8 into negative 270 gives you what? 27.55 sine theta. Because we don't know, you treat it like x. You don't know what it is, so you keep it there. But this is what? This is our time. So we can take this is our time, we can take this and substitute it there. We have our time. When you multiply it by 2, of course it will leave you with theta and theta there. But it is able to give us an idea of the horizontal displacement. Okay, let's do that. 270 cos theta times 27.55 sine theta times 2. Okay, 270 times 27.55 times 2. 148 7 cos theta sine theta. Because we do not know cos theta is how much, sine theta is how much. If we knew the theta, it would give us an answer, but we don't know how much it is, so we'll write it like that. Cos theta sine theta, this is our horizontal displacement, which is this. That's what I'm saying. This is yeah? It is the displacement from A up until B. But it has not given us the exact answer. We still need to solve out the theta. But we have only dealt with this side. And then this key, if they say it is 3 times, this guy is 3 times as much as the maximum height. If they say it is double, we would have used 2. If they say it's 4 times, we would have used 4. So that is why that relationship between the horizontal displacement and the vertical displacement is very important. You read the question carefully and then that's what you do relating. If you change that number, then everything is changed. The angle changes. Alright? So at least from this, we have managed to get this. Then the maximum height, vertical displacement from there up to there. With the same information, I'm going to need that. With the same information that we have, so on this side, what we have is 14877 cos theta sine theta is equal to 3 times whatever. Alright, so on this vertical height, the initial velocity, vertical now, is 270 sine theta. Final velocity is 0. Gravity, negative 9.8. Then they ask us what is your displacement, your maximum height. That's what we are solving for. V squared is equals to U squared plus 2 gravity, your displacement. Okay. Then you change the subject to the formula. V squared minus U squared is equals to 2 gravity S. We divide by 2 and gravity. Okay, these 2 will cancel out. Then we remain with this. V squared minus U squared. Okay, I'm putting the V just for differentiating the S for horizontal S to vertical. Okay. So going upwards, this is 0 square minus initial velocity 270 sine theta. Okay, now this is square over 2 times negative 9.8 is equals to your SV. It's separate. Square root, you square, not square root, square of 270 is how much? 270, not negative. No, not the negative. Do not square the negative. Just 270 square. 72900. Okay? Sine square theta. Also, this one is going to be square. Okay? It's a negative. That negative remains. You do not square the negative, or else it will give you a positive number. 2 times negative 19.6. Actually, I'm thinking of the answer 19.6. 19.6 is equals to SV. Alright, so now this negative 19.6 will go in the negative 7 to 900. So you take this number, you place it there. 3719,388 sine square. Don't forget the square. That. Okay, makes sense. Yeah.
So now, from this stage now, our physics assignment is now just mathematics. Now just mathematics.
Yes, so okay, just to make life easy, let's divide this side. 14877 sine theta. This we divide by 14877 sine sine theta. This theta and that theta will cancel this into that, will give us cos theta, to give us a 1 cos theta. So now you can divide these ones. 0.75. Okay, this is just sine into square root of sine. Will give us only sine theta. Okay, makes sense. Yeah. We divide by cos theta. We divide by cos theta. This and that will give us 1. This will give us 0.75 tan theta, because sine over cos is tan. Okay, then what do we do? Let's cancel that. Tan theta is equals to 1 over 0. Yeah, this is that. This, I can't remember. Okay, tan inverse theta is tan inverse 1 over 0.75 theta. Now you punch that degrees. Okay. 188